Okay, so hello everyone. In this video, what we're going to be doing is, so we've already done derivatives of most of the functions that we've already done, right? I was going to do log functions. The only thing about that is, so basically, the only thing about it is that in reality, they're a little bit, I mean, I can go over one of them very briefly, but the only thing is that, apparently with logarithmic functions, like actual logarithmic functions, it's a little bit harder. I'll do my best. I'm gonna do, so let me just go ahead and do ddx of the natural log of x squared sine x over 2x plus 1. Now this one, I did attempt the first time and I actually did it wrong. The one thing you're going to want to do here is, instead of trying to find, like, using a quotient rule for the inside part, what you're going to want to do is split this into two different logarithms. So this is really just going to be, so remember how I said from college algebra, ln of x over y is really just ln of x minus ln of y. So in reality, this is going to be natural log of x squared sine x minus the natural log of 2x plus 1. Now, another thing is that this, so if we look at this specific function, or this specific the specific term, or this part here, this expression, I mean. So if we look at that expression, we want to go ahead and split it up into, using the product rule, so AB, right? So ln of AB, so remember ln of xy, or natural log of xy, is really just, and let me color code this really quick so that it can look more clear. So this is the product rule for logarithms, right? So anytime we take the natural log of a multiple of two numbers or two factors, we usually say ln of, or natural log of x plus natural log of y. So the way that we can rewrite this is, we can say that this is equal to the ln of x squared plus the natural log of sine of x. And then this can be minus natural log of 2x plus 1. So here we can say this is the natural log of x squared plus the natural log of sine of x minus the natural log of 2x plus 1. Now you're not going to do anything with the natural log of 2x plus 1 because that cannot be simplified further. I feel like a lot of people keep forgetting that, like, one of the common mistakes that people make is that they believe that this is equal to ln of a plus ln of b, and this is not true. Okay, so that is not true, okay? You don't want to do that. So we're just going to leave it like that. Now, ln of x squared, we can use the power rule that is when we have ln of a raised to the x power, this is really just x natural log of a. Okay, so this can be 2 natural log of x, and then plus the natural log of sine of x, and then minus the natural log of 2x plus 1. Now this is a lot easier than having to do this, okay? And the reason why is because, you know, now we don't have to really use quotient rule for that, right? It's a lot easier now. So basically we have 2, and it's going to be, so if we want to find the derivative, let's say we have dy dx is equal to, and then we're going to say that this is equal to 2 times the derivative of ln of x plus, and then we're going to do, so it's going to be, let's say that this is ln of u, where sine of x is equal to u, and then let's say that this is equal to ln of 2x, or ln of v, being that 2x plus 1 is v, right? So we're going to say that this is equal to 2, and then the derivative of ln of x, remember, is just 1 over x, so you have times 1 over x, plus, and then the derivative of the ln of u is just going to be 1 over u times u prime, and we set u equal to sine of x, right? And then minus the natural log of v, so the derivative of the natural log of v is going to be 1 over v times v prime, and v is equal to 2x plus 1. So if we find u prime and v prime, so u prime is going to be cosine x, so we have 2 over x plus, and we have, it's going to be plus u prime over u plus v prime over v. So then u prime, in reality, so the way that I'm doing it is I'm saying that this part is what this is, okay? And for those of you who understand better with color coding, this is what I'm saying right here. So this is u, and u prime is another one. So basically, if I do it this way, so u prime, and then I'm going to make u prime, I'm going to make it green. So this is what this is, and then u is the blue one, so this is what u is, right? And then v prime, so v is the pink one, so we have this part is v, and then v prime, if we write v prime is just 2, right? So we can say that v prime is this one here, right? So really we have something like this. Hold on. So we're going to have something like that, right? Now, so basically we're going to have this is equal to 2 over x plus, and then cosine of x over whatever sine, so it's going to be over sine of x plus, and then v prime is 2, and v is 2x plus 1. So this is going to be 2 over x, and then cosine of x over sine of x, that's cotangent of x, plus 2 over 2x plus 1. And so, in reality, this is what the derivative would be for this one. So you see everything that we did. We converted it to what is it called? To a difference of two logarithms. And then we went ahead and we just went step by step. And we rewrote it again. We converted it into two logarithms again. With the first part, we said that this was ln of x squared plus ln of sine of x. We used power rule for ln of x squared. And then we said that that was 2 ln of x. And then we said plus ln of sine of x minus ln of 2x plus 1. We set u equal to sine of x and v equal to 2x plus 1 because it's ln of u plus minus ln of v. That's to make it easier. And then we said that v prime was 2 and that u was cosine, or u prime was cosine of x and u was sine of x, right? So when we used that, we went like this over here. This is a rule that they do in Cal 1. So then we just followed this rule and we did it this way. So yeah. Now we're gonna go on to another one. Let's see. I'm trying to see exactly what other ones there are. So oh, and this was minus, my bad. Give me 1 second, guys. I don't know why my OneNote keeps kind of like freezing. My bad, this part was minus, not plus. So if I ever make a mistake on any of my videos, guys, let me know. Because sometimes I make mistakes and I don't notice it until the end. Or I don't notice it until I actually watch the video. So if anybody watches these, let me know if I make a mistake. Sorry guys, give me 1 second. I know, it was like a long pause. So this is your answer for this one. So we're gonna go on to another one. Let me see. We're gonna try to just do the log of or the logarithm one. So there are two rules, or rather, there's one rule that we need to know for logs. Now, if we have, so given f of x is equal to log base b, or let's just say, given y equals log base b of u, that means that y prime will be, it's gonna be, oh my, I forgot the formula. Oh, it's been a while. Let me see. It was something like something uln of a. Give me 1 second. It's going to be u prime over u ln of a. So that it's not that different from the other one, because remember we said that when we have the derivative of u, that's just, it's in reality it's going to be u over u prime. So this one is not really that different. But it's very important to not confuse them. They're almost the same. That's the thing. It's tricky. It's almost the same, but it's not. U does not include. So the 1 over u does not include or I'm sorry. This was u prime over u. Oh my goodness. It's like this. So this one, they're almost the same, except the derivative of 1 over u does not include ln of a. So that's the difference, and you have to be careful. So let's say we had the problem f of x equals the log base 3 of x, right? We want to find f prime of x. So if we do that, we have remember, it's so the derivative of log base a of u is really just u prime over u ln of a. Or this one's supposed to be ln of b. Oh my goodness. I'm so sorry, guys. It's like that, and then you, like this, right? Now, this is the formula. So what does that mean? That means that u here, u equals x. So that means that du is going to be, it's really just going to be 1 because we're taking the derivative with respect to x. So really it's going to be dx over dx, which is just really 1, right? So that means that u prime is 1 because, like I said, du is the same as u prime. So that's one thing I want to make like that, right? I want to make that very clear. And let's see. So we're gonna have u prime is 1, so we're gonna have 1 over, and then we're gonna do x, because that's what u is, right? U equals x, and then we're going to take the natural log of whatever our a value is. This is a equals 3, ln of 3. So really this is the derivative, 1 over x ln of 3. Now, there are tougher ones, and we're going to go over them. So we have, what if we have f of x equals the log base 3 of 2x? Okay. Now, this one, we can say that f prime of x, and like I said, guys, you're gonna have to know your algebraic rules for this. Like, it's like I said from the beginning, when you do calculus, you're gonna have to know a lot of algebra, and that's why we went over algebra. We went over a lot of algebra. We went over a lot of algebra at the beginning, so basically f prime of x for this one. So remember, log base a of u, the derivative, so this prime is really just u prime over u ln of a. Okay, now what is u prime? U is equal to 2x, right? So what is u prime? U prime is just 2 and yeah, it's just going to be 2. Now here this means that f prime of x is going to be u prime, so we're going to do 2, that's u prime, right? Because here's our formula, u prime over u ln of a, so it's going to be 2 over 2 ln of 3. Or, sorry, 2x ln of 3, excuse me. And maybe I should color code this. Oh, the thing is that, so ln of a, like this, and let's make u prime, let's make that red. So really we have something like this. Okay, and so u is equal to 2x. So really this would be equal to, and also a equals 2, or 3, excuse me. So really we're gonna have, so it's gonna be u prime, so we have 2 over, and then we have 2x over here, and then ln of 3, like that. So then once you simplify, you have 2 over 2x ln of 3. So you can simplify it, you can take out the 2, cross it out, so you have f prime of x is equal to 1 over x ln of 3. This would be your answer, okay? Now, let's go over a little bit tougher ones, a little more tougher ones. So let's pretend, so let's see, hold on. Let me look for some. Let's go over one that's, okay, this one's a little tougher. Now, like I said, you can convert this, like you can expand this, okay? You don't have to, so f of x is equal to log base 6 of the square root of 2x plus 1. You can expand it. You don't have to do it like this. I mean, so you can say the following. You can say log base 6, and then remember when I said that the square root of u is really just u to the 1/2 power? So you can say that this is equal to 2x plus 1 raised to the 1/2 power, right? And really, if you think about it, so anytime you have ln of a to the 1/2, that can be equal to ln of a to the 1/2, like this, okay? So really you don't have to, I mean, or you can say log base b of a to the 1/2, or to the x over y is really log base b of a and to the x over y. But you have to make sure that you put brackets on it. So really this is going to be equal to this. Now you can move the power to the front. You can say that this is equal to 1/2 log base of 2x plus 1. And that makes it a little easier. It's a little bit easier now, because now all we have to do is really just say that the derivative, so if we have f of x is equal to this, then that means that f prime of x is really just 1/2 times the derivative of log base 6 of 2x plus 1. You can take out the constant. Anytime we have, so remember this rule, c times f of x, the derivative of this is really just c times the derivative of f of x. Okay, that's how it works. We can take out the constant, so we have 1/2, and the derivative of log base 6 of 2x plus 1, remember? So we have log base b of u, or we're going to say log base a of u. The derivative of this is really just u prime over u ln of a. Okay, so what is u prime? U prime, so if we look at this, u is equal to 2x plus 1. U prime is going to be 2, is going to be, yeah, just 2, right? So, because that's the derivative of u, right? So then we have that this is equal to 1/2, and then it's going to be u prime, so 2 over, and then whatever 2x plus 1 was, or whatever u was, the original u, 2x plus 1 times the natural log of 6. So you can cancel this out, and you can say that this is really just 1 over ln of 6 times 2x plus 1. Or you can simplify it even further and say this is 1 over ln, or 1 over 2x ln of 6 plus ln of 6. Both of these work, okay? This is just the factored form. All right. So let's see. Hold on. I'm trying to look for more problems. I'm not sure if I went over power, like the power function ones. In reality, I don't remember. Give me 1 second. Okay, so I did not go over derivatives of power functions. The thing is, with power functions, it's very similar to log, and that's the bad thing, because instead of multiplying, and the thing is, they're very similar, and maybe I should do that in the next video, but yeah, like I really think that that we should do that in another video, because I really don't want to confuse anybody. Those are very similar to derivatives of logs. I'm gonna just do one more in this video, and then I'll go ahead and move on, or end the video here. So basically, let's see, hold on. So let's do these problems, or let's do this problem. This one is f of x equals x squared ln of 9x, alright, or natural log of 9x. And we have to find the derivative of this. So what you're going to do is you're going to use power rule. Now the way that I would do this is I would just go ahead and say use power rule. So in reality, f equals x squared, and remember that, or did I say power rule? I mean product rule. Excuse me, product rule, not power rule. So product rule is f prime g plus g prime f, right? And with this one, so we know that f is x squared, right? And g is ln of 9x. So this is going to be x squared prime times natural log of 9x plus natural log of 9x prime times x squared. So then we have 2x times the natural log of 9x plus it's going to be, what will it be? It's going to be, so this one, in reality, remember, it's really going to be 1 over 9x times 9x prime. Because remember, it's 1 over whatever's on the inside, and then times, because remember, ln of u, the derivative, is really just 1 over u times u prime. So this is what this is, and then times x squared. So then we have 2x ln of 9x plus, and then we have 1 over 9x times 9 times x squared. So then we have 2x ln of 9x, and then the 9 cancels out, and then we have plus x squared over x, which is really 2x natural log of 9x plus x. And or you can also do it like this, x times 2 natural log of 9 plus 1, or natural log of 9x. Okay, and that's how you would do that one. I'm trying to see what other ones there are. If I say, for example, and I don't know why it keeps freezing. Sorry guys, give me a second. Thing is that it keeps freezing a lot. So let's see, hold on. Where was I? Okay, okay, well I guess I didn't say what I put. But yeah, that's what that problem was. I'm not sure why. I'm not sure why it did not save what I had put on here. But anyways, I'm gonna go ahead and end the video here, guys. If anybody has any questions, let me know. In the next video, we're gonna do power functions. So, and then after that, we are finally gonna get into, well, there's also inverse trig functions, which it's a lot. And then, so basically, for the next few videos, and I believe, let me just go ahead and list off the things that we still have to review, or we still have to go over. Number one, power function derivatives. Number two, inverse trig function derivatives. And then let me think. I'm thinking about another thing. And then number three, mix of all derivatives. And after we're done with this, we're finally gonna get into like actually doing some applications of derivatives, which involves like finding the how do I say it? The critical points and the increasing and decreasing intervals of f of x and stuff like that. I believe this is all that's left of, for the derivatives portion. And then, and also we have to learn how to do related rates. And then we'll get into some basic integration after that. But yeah, it's a lot of things. And, but with that being said, guys, I really hope this video helps. Let me know if you have any questions. Thank you so much for watching. Please like, comment, and/or subscribe. And I will see you guys in the next video. Bye, guys.